Great, thank you. Good evening, everyone, and welcome to the 6th Coast Guard Tech Talks workshop. These workshops are jointly sponsored by the U.S. Coast Guard, the Coast Guard Auxiliary, and the Boy Scouts of America's Sea Scout program. My name is Bruce Johnson, and I serve as Chief of the Coast Guard Auxiliary's youth programs. Our co-host is Josh Gilliland, Chair of the National Sea Scout Communications and Marketing Team. Josh will be coordinating your questions in the third part of the program. Coast Guard Tech Talks are held monthly on the fourth Tuesday of the month at 2100 Eastern, 2000 Central, 1900 Mountain, and 1800 Pacific time. Each program focuses on a single science, technology, engineering, mathematics, or STEM topic. These topics are chosen to support the Sea Scout Advancement Program. We'll be skipping November and December due to the holidays and will return in January. January's Tech Talks workshop will be on Maritime Safety Equipment, Ordinary Requirement 5B. Tonight's topic is marine radio. Our presenter is Dr. Nick Lomangino, the Division Commander of Coast Guard Auxiliary Division 25, the Potomac Guardians. Nick joined the Coast Guard Auxiliary in 2014 and holds the Operations Specialist rating. He serves as a radio watchstander at Coast Guard Station, Washington. Dr. Lomangino earned his amateur radio license in high school and holds an FCC extra class radio license. He earned a Bachelor of Science degree in computer science and is a physician board certified in internal medicine and forensic medicine. He has been a flight surgeon for 30 years and served with the Air Force in theater as a flight surgeon in both Desert Storm operations of Gulf War I. One last thing, we've muted your microphones to make it easier for everyone to hear. If you have questions, please type them into the chat box or Q&A. Actually, Q&A is probably better. Josh will be monitoring the Q&A and will be sure to leave time to answer your question. So without any further ado, let's welcome Dr. Nick Lomangino.
Thank you, Bruce, and welcome everybody. I appreciate the opportunity to speak to everybody and present some information about Coast Guard radio comms and in general radio communications, so a little bit of the science and technology behind it, with the hopes to stimulate your further study in this area. So let me. Okay, so tonight we're going to cover a little bit about NavCen, which is the Coast Guard Center for Maritime Telecommunications. A little bit about AIS, Rescue 21, and DSC, and I'll explain what that means a little bit later on. Radiotelephone Systems, the types and uses, a little bit about a transmitter and antenna and how they work, and the technical aspects of radio waves. And I've have some practical exercises for you to be able to do on your own, and we'll open it up to questions as soon as we're done. So if you just Google NavCen, it'll take you to the Coast Guard Navigation Center. And if you look on the left side over here, there's always a navigation bar, and you can see selected areas. And we're going to touch on a little bit of those in this evening's talk.
Nick, you're not sharing your screen yet.
Oh, okay. So let me back up just a little bit. So I thought we had that solved. Just give me a second. Okay. I think we're on track now, right? So this is the NavCent area. Can you see that now, Bruce?
What you want to do is flip your display. You're showing your screen rather than the
Okay.
go to display settings and pick the other one.
How's that?
Perfect. You got it.
Okay. All right. Appreciate everybody's uh, indulgence on this. And so this is you can see my pointer as well, right? So this is the navigation bar that I was talking to you about. And you can, as soon as you go to the navcent.gov, uh, you'll be able to see all of that. So just a little bit about the AIS. This is Automatic Identification System. And this is very similar to air traffic control, where an aircraft may be squawking a code. Same thing that we have in maritime service. Um, many boats and ships have the capability of taking a GPS signal and then putting that into their radio that broadcasts on a periodic basis, and that can be visualized by the Coast Guard and Department of Homeland Security and others. So a little bit about Rescue 21. Rescue 21 was established to create an area that actually uh, is a way of doing location finding. Vessels in distress can be easily located with Rescue 21. There are several towers that line the coast and the Great Lakes areas, and a 1 watt signal 1 foot above the sea level, 20 miles out, can be detected by the Coast Guard. And we'll just show you some of those um, that capability. Again, this Rescue 21 is found in this area in the maritime section of the NavCent. So basically, how does Rescue 21 work? Like I said, we've got towers all around the coastline and Great Lakes areas, and they can pick up a signal by a vessel. Could be portable. Somebody could be on a watercraft. It could be many miles off, 20 miles off coast. I have a friend that does a sea kayaking, and he typically goes out 15, 20 miles. And so that can be picked up. That gets sent into a central communications area, and that gets fed out to different stations. So when we're sitting at a Coast Guard station, we have a visual reference of any areas towers that we can dial in on. Um, of course, this also gets communicated to headquarters. There's satellite communication as well. And in case of a disaster, if a section is destroyed by weather or any other activities, the Coast Guard can put up a disaster recovery system, which takes the place of a tower, and they can get pretty much operational within a 24-hour period. And so this is an actual view of all the different radio stations that's in our sector of Maryland, Virginia, and North Carolina. You'll see all those towers. When I'm in Station Washington, which is over here, we can see towers in Leonardtown and also Prince George's and Alexandria. So those are the three towers that we look at, which essentially covers the Potomac River from DC Metro down to the Henry Nice Bridge. And this is a field strength survey of the area that you could see all the different, again, the radio stations. These are the King George, Leonardtown, and Alexandria. So this is, we cover the area down to about here. And this is an area just depicting the North Carolina sector as well. So just a little bit about DSC. What I'd like you to do is, in your own time, go to a the YouTube and just put in ICOM, um, digital selective calling, and it's a short little video. I don't have the audio hooked up right now, so I'm going to bypass that. But the idea is that when you get a radio, you can register it with NOAA, FCC, or U.S. boats, and they will give you an MMSI number. You go onto the internet, log in, particular information about your craft, so that if you did get into trouble, all you needed to do was flick that cover switch, hit distress, and the Coast Guard would immediately be notified of your location, and the fact that you're calling out for a distress signal. It could also be used for group calling, if you, not necessarily distress, but you can use the DSC function if you go out boating with a group of people and you want to stay in contact with another. It's a way of doing a digital selective calling. You don't necessarily go on voice right away. You can put a signal out, and then you switch to voice to move you to a different channel. So all the digital transmission gets put out on channel 70, but you would switch to an operation channel um, when actually talking by voice. So So a little bit about radiotelephone systems. They're basically two marine voice systems. There's a ship-to-ship and ship-to-shore communications. Um, there's HF communications, which stands for high-frequency communications, and that's usually between the 3 and 30 megahertz range. Um, the VHF is FM based, and the frequency range is 156 to 162. Now, this is basically what Rescue 21 sits on. It operates on VHF. That's a line of sight limitation. That's why when you look at the height of the different towers, it will be able to look out about 20 miles, but that's about it. A single sideband is for long distance communications, and we'll get into that a little bit later so you can see how that works. Um, so the VHF channels are separated, VHF frequencies are separated into channels. And the whole idea of channelizing radio communications is to avoid one station interfering with another station. There's enough separation that the bandwidth required for the voice communication will not spill over into the other channel or other frequency. The idea is whenever you're using radio communications, you want that communication to be as clear as possible without disruption. Any type of disruption in the signal will cause the need to repeat the message, which is commonly seen in the single sideband, but because single sideband is not channelized, but VHF is. And the three basic functions that's used for auxiliary is for safety, operational, and business communications are the three main categories of communications within the Coast Guard. So safety is the highest priority. It's the international distress and calling frequencies. Years ago, 2182 kilohertz, which was in the medium frequency band range, was used for long range um, alerting distress signals. The Coast Guard no longer monitors that frequency, but many other organizations still do monitor that, and I believe ship to ship will monitor that once out into in the oceans. Along the shore, like I said, channel 16 is the emergency channel, and that's 156.8 megahertz. And that frequency is monitored by the Coast Guard. It's also used for calling and answering. So apart from, a Mayday call, if you wanted to call somebody, everybody's tuned to 16. We all have an obligation to provide assistance if within our capability. So everybody monitors 16. And so if somebody wanted to call someone else, you would put out that call, and then you'd say, as soon as the person came back, you'd say, switch to, and then you switch to another frequency. So it's for calling, switching to a working frequency, and conduct your business or whatever communications you wanted on that working non-emergency channel. The idea is that you can basically call, answer, and switch, leaving the frequency open for any distress calls that may come through. And it's also the frequency that the Coast Guard, of course, performs radio watch. Not only looking for recreational boats that may have a problem, but we also use that frequency as well for our own boats that may be out on the water. Um, it's also a frequency that the Coast Guard uses for weather broadcasts and safety broadcasts. If there's any type of a situation that poses a safety hazard to safe navigation or movement on the waterways, the Coast Guard will put those types of broadcasts. And then there's other, operational navigational movements. If you have two ships passing each other, there's a communication. Usually, a channel 13 is a bridge-to-bridge communication, so the captains can communicate clearly which direction they're moving in, so as to avoid collision. And then economic and commercial businesses, clearly if somebody has a marina or you're calling for a sea tow, uh, that would be for the economic and business. So when we look at radio frequencies, radio spectrum in the United States, this is going to be one of your assignments. Go on and Google radio frequency spectrum, and I will show you that at the end. But this maps all the frequencies that are allocated to the U.S. and within each one of those areas, what service or organization is allowed to operate on that section on those frequencies. And so if we looked at marine VHF, it would be in that area. And if we drill down a little bit more, you could see all the different channels that would be available for Coast Guard communications. So what about radio waves? What is a radio wave? Well, wave phenomenon is very interesting, and it's used to describe light, radio, electromagnetic radiation, and even sound waves. And you can see the typical example is dropping a pebble in the water and then seeing those ripples. Well, each one of those, that's basically, it's a wave phenomenon, and as time goes on, the amplitude drops down uh, over the initial uh, impact, the initial disturbance, if you will, and then it drops down over time. Well, the length from one peak to the other is called the wavelength. Um, and basically that's how we measure radio frequencies. Now, we put how many waves are in a second, and if we're talking about 156.8 megahertz, that's 156.8 million times a second that wave is going up and down. And when I say up and down, it's really a voltage, where voltage goes up in one direction, hits the peak, reverses direction and comes down, hits the trough, and goes up again to the peak. Peak voltage, positive and negative voltage, describes how a radio frequency works. So now, how does actually radio frequency propagate itself in the air? Well, there are two fields. There's a magnetic field and an electric field, and they're at 90 degrees displacement from one another. As the magnetic field collapses, it generates the electric field and vice versa. So basically, energy is, I view it as energy being thrown back and forth, um, between those two fields, with the wave itself moving essentially at the speed of light. Now, there are some things that interfere with that speed. Um, if it's electrical current across a wire, the thickness of the wire with the metal that it's made has a factor that reduces that speed of light down somewhat. Uh, it could be weather conditions, humidity in the air. All those things can affect the speed of the transmission, but we usually think in terms of radio movement in free space. It's 300 divided by the frequency in megahertz gives us the wavelength. So what about the types of waves? Well, we talked about this as an electromagnetic phenomenon, um, but there are layers in the ionosphere, the troposphere, that can absorb and reflect these radio waves. So a ground wave is an example of the Rescue 21. It goes from the tower to the radio antenna surface. It doesn't radiate out into space. The troposphere is about 5 miles high over the poles and 11 miles high over the equator. And that can have an effect on the radio waves. Typically, like I said, VHF is line of sight, but many a times I would be in Maryland and talking to a station in Philadelphia or even further, where that electromagnetic energy gets trapped between two air masses, and rather than going straight up, it actually travels horizontally within that, comes down a different area, and typically those conversations don't last for more than a few minutes because of weather shifts and wind and what have you. But the ionosphere goes anywhere from 50 to 250 miles high, and depending upon the day or night, the degree of ionization that occurs um, will have also effect on those radio waves. And we'll see that in a slide or two. So what is a sky wave and the ionosphere? How does that work? So if you got two ships out at sea, their radio wave is going to the ionosphere and it reflects back to Earth. And typically we've seen that in AM transmissions. In my younger years, when you had an AM radio, I could be in New York and listening to a radio in a station in Texas. Well, that's how we heard that. The electromagnetic energy from the radio station in Texas went up to the ionosphere, dropped back down, and found itself in New York. Now, if you happen to be living in Tennessee, between those spots, you may not hear that, but the area between the two, the receiver and transmitter, you can have effective communication. Again, that only lasts a short time as well. Now, depending on the frequency, time of day, there's a maximum frequency utilization. Sometimes it doesn't get reflected back, but it'll go right out through the ionosphere out into outer space. And that's basically how we talk to, the International Space Station, or when we had astronauts on the moon and planned missions to Mars. We're going to take advantage of those frequencies that will cut through the ionosphere. So when we take a look at a medium frequency propagation, you could see that we're a little bit closer. That's a sky wave. This over here at the bottom would be the ground wave, and the area in between would be called the skip zone. So there's your ground wave. That's a skip zone. So nothing's heard in those areas there, but the two ships can communicate, and that's just a phenomenon. Again, type of day, amount of ionization, and what frequencies are used. VHF propagation is straight line of sight, just like we talked. Now, the interesting thing about line of sight is that the line of sight is slightly longer than the visual. So the radio will see a station beyond what you will be able to see. And that's just a phenomenon of how the radio wave travels across the ground and over the ocean as well. So it's about 15% further than the visual horizon. Ship-to-ship calls. So this is important in terms of how you would make a call. The very first thing you do whenever you're making a call is to listen to make sure the frequency is clear. Remember, I said early on in the presentation that you want to have effective communication. And if somebody's transmitting and utilizing that frequency, and you power up your radio and start transmitting, you will clearly interfere with that station. And that doesn't provide any benefit to anyone. But if you don't hear anybody, that's a good opportunity for you to then put out your call. Bear in mind that because of that skip phenomenon, you may be hearing one station, but you're not hearing the station they're communicating with. And usually they'll come back and say, stand by, communicating with another station, and they'll get back to you. So you just basically be patient, listen until that station comes back to you. But otherwise than that, if it's clear, you make your call, and then in maritime use, recreational boating, typically you don't have an FCC license, you're not issued an FCC call, but you use your vessel name as your call. Now there are some instances where you will get an official FCC call. In the Coast Guard, we do have calls issued for our HF stations. We don't issue call signs for our VHF stations or any boats that we have out on the water. But typically, what we'll use is the length of the boat and the last 3 or 4 characters of its registration. So, for example, we might have a Coast Guard boat, and the call sign for that Coast Guard would be Coast Guard. Let's say the boat was a 29-foot small boat, Coast Guard 29110. And so the last 3 digits of the registration number was 110, and that's what we'd use for the call. Likewise, if it was an auxiliary boat, we would say auxiliary 24112, where 24 was the length of the auxiliary boat. And that's what we'd use as the call. Now, the idea is, again, not to tie up the frequency, so you repeat the call twice, wait 2 minutes to see if you can connect. If you fail to connect, you wait 15 minutes before repeating the cycle. Now, at the end of the call, you don't have to say, when you first make the call, you say, well, you call, say, switch to channel 68. You don't have to say returning to 16. Again, that's tying up the airways unnecessarily, and everybody presumes that you're going to go back to the monitoring emergency channel frequency. FCC regulations is that you don't necessarily have to exchange your call after each communication, but after every 10 minutes, you do need to. Now, this 15-minute wait period doesn't apply if there's emergency communications. In that case, you would just you would keep calling if it was a bona fide emergency. So here's an example of a ship-to-ship call. First one says, Minnow, Minnow, this is Bay Breeze over, okay? And then Bay Breeze will hear you say, Bay Breeze, this is Minnow, over. And Minnow, shift to channel 68, over. Now, here's the other thing. Every time there's an end of the transmission, you use the pro word over, which basically is telling the other station that you are no longer communicating and you expect them to come back to you. And then this is a minnow, Wilco out. So Wilco is a pro word that means will comply. And out is kind of like hanging up the phone. Out means I don't expect to say anything else at that particular point. Well, obviously in this situation, they're going to channel 68. So they do the calling and answering on channel 16, switch to 68, in which case we'll go out. They both turn to 68 and conduct their business, whatever they wanted to communicate to each other. So now after they switch to the frequency, Minnow, this is Bay Bridge over. And then Bay Bridge comes out, Bay Breeze, this is Minnow over. I kept saying bridge, didn't I? This is Bay Breeze, and then you say your message, over. This is Minnow, respond to the message, over. Again, at the end of each one, they're going to say over. And at the end of the communication, you say, this is a Bay Breeze, out. Out again means ending the conversation, and it's considered bad radio protocol if you say over and out. Over doesn't fit with out. Over means that I'm finished talking and I'm expecting you to come back, and out means I'm finished talking and I don't expect you. So you never say over and out. It's considered poor form. So what are types of calls that we consider from an operational call, a safety? They're distress, urgency, and safety messages. And there really is a broadcast to any and all. Unlike the prior example where you're calling one specific station, these calls, you're calling anybody who's listening, okay? So there's not a specific station. Calls are made on channel 16. It's because, as I said before, everybody is listening to 16, or at least should be. Now, the highest priority is Mayday, which comes from the French, means help me. It's got the highest priority, and whenever you hear that, you stop all communications, no matter where you are in the middle of it, because there's grave or imminent danger, and somebody's asking for immediate assistance. If you hear pawn, that's an urgent message. It's a safety of ship. So that may be that, a ship, let's say, lost its power, and they might be in a navigational channel. Um, they're going to need some urgent assistance, but there's not necessarily imminent danger to life on board. And then security messages may be of safety, navigation, or meteorological warning. For example, somebody may have seen a large log floating in the Potomac, and there may be a security message that goes out to boaters to keep a lookout if they're in a particular area. So the important things when you're doing a Mayday call, you want to know what's the vessel name, and you want to know where they are. GPS coordinates are best. Bearings or approximate location is the next best. And then you want to know what is the nature of the distress, what type of assistance required, number of people on board. I usually put that as a higher priority. I want to know how many souls are at risk in a Mayday call, because if somebody goes out and do a search and rescue, I want to make sure that we collect all the people that may have been in that situation. The condition of the boat, the seaworthiness, is it sinking? Is there a fire? That sends it gives you a sense of what type of resources you might need, depending upon how far they were away from vessels that are being dispatched, and then a description of the vessel. And then before you stop your communication, you want to be able to establish a frequency and a schedule for maintaining constant contact with them. Maybe every 5 minutes, maybe every 15 minutes, depending upon the nature of the emergency. Now, ship-to-shore calls are a lot different. Years ago, there used to be a marine operator who who would take that call, and basically you would call that marine operator by radio, and that marine operator would actually then um, patch you in on a standard telephone line. Nowadays, cell phones have pretty much made the ship-to-shore function somewhat obsolete, but the issue there is you still need to be near the shore in order to use that. The further you go out, you're not going to hit cell coverage, and then you're going to have to look at HF communications if you go beyond 20 miles. And that's all I'm going to say about that. So again, answering procedures, you always you tune to 16. Now, a lot of channels have got a dual watch feature. Channel 9 is the alternate. And like I said, the Coast Guard doesn't monitor 2182, although other entities do. And so the dual watch capability is that the electronics of the radio just switches back and forth between those two frequencies so fast. And whenever there's actual message going across it, it stops whenever it actually hears uh, radio communications or that a modulated signal coming across that line. And so here's some of the working channels for VHF that you should familiarize yourself. These are Coast Guard working stations. Channel 23 pretty much is used by auxiliarists communicating with the Coast Guard. Liaison station, this is when the Coast Guard is talking to the general public. They'll use channel 22. And that's where they'll put out some of their safety broadcast messages as well on 22. So what about becoming an auxiliarist and a facility operator? Um, in order to become an operator, you need to become TCO qualified. That's a special training course to basically make sure people understand the basics of a radio operation. Again, this is mainly VHF nowadays, but the Coast Guard Auxiliary does have a high frequency program. In fact, I'm the ADSO CM for the District 5 South Auxiliary District. One last thing about radio communications, if anybody's really interested in learning more about radio, and I'll show you the amateur radio organization that you can learn more about. But this is a system that allows people basically anywhere they are in the world to put out a radio signal, and that gets injected into the internet and becomes a regular email message. So you can basically get email if you happen to be on a sailboat out on the ocean. And that's it. I appreciate your time. I realize I went through that pretty quickly, but ready to hear some questions. Now, I do have just one more thing, if I could show you. I can figure out how to navigate this. Let me shrink this down. Uh, I want to do a new share, and I want to go to these stations. This is kind of your assignments that you could do on your own. Great website, websdr.org. And I'll provide these slides so you, if you can't write it down, you can you'll be able to see the presentation. But basically, these are radio stations located all throughout the world, and the frequencies that they monitor, the types of antennas they use to monitor those, and basically they put out they broadcast the signals they pick up, and you could see all the different countries, all the different frequencies that you can monitor. Sometimes these is digital, and you might need to get the digital software to decode that. But you don't need any expensive equipment. If you got a computer and a browser, you can listen in and learn about radio. SDR stands for Software Defined Radio. So instead of the old days when we had transistors or vacuum tubes, everything is done through digital processing now. And radio spectrum is what I showed you before. And again, you could see all the different types of uses for radio frequency spectrum. And there's a chart. This is the chart that was in the presentation. Just Google radio spectrum chart. You can blow that up and examine that a little bit further. And lastly, this is the Amateur Radio Relay League. I don't get any royalties except to share a hobby that I've had for the last 55, 60 years. That you might enjoy. And if anybody's interested in learning more about becoming an amateur radio enthusiast or operator, I will make myself available to this group to help mentor you through the process of getting an FCC license. And that's it. That's the end of my presentation. Thanks for your time, and I stand by for your questions.
Well, thank you, Doctor. We have one question out of the gate, and I know we're going to get more. And this question is, what's the best way to practice radio communications?
The best way of doing it is actually to do it. So if you can get with a friend and go through some protocols of making a call. The way the standard protocol is, you're going to give the call sign of the station you want to contact, and then you say your station identification, so they know who's calling. They know who is being called and who's calling, and just practice it. But it's great, you know, whether you have a small little family radio service, you can get them pretty cheap in you know, any of the big box stores. And you know, just get on the air and practice that. The biggest thing is, I call it mic fright. When somebody's talking into a radio for the first time, there's a certain degree of shyness of it, and getting over that shyness is, you know, you're going to be smooth sailing after that. Knowing the procedures on how to call and make yourself look professional. Clearly, if you're working on behalf of the Coast Guard, you have to be able to convey confidence, calmness, calm the other party down. Usually, if it's an emergency, they may have a lot of pressured voice. They may sound like me talking pressured and rapidly because I wanted to get through all this material, and so calming them down so you can hear the message to provide them the type of resources they need. But that's the best thing, is just doing it and learning the process, learning the protocol. Hope that answered it.
Yeah, fantastic answer. I would just add that the FRS type radios, the family frequency, you can get those off Amazon like for under $25, and that could be a great way to practice. And this highlights, we could work up some hypotheticals that people can download. So there's definitely a variety of ways that we can help you.
Yeah.
Next question. do you need 2 radios to use VHF and MF?
So MF would be medium frequency. Well, for all radios, if you transmit and receive. So you don't necessarily have to have 2 radios, but if, for example, I've got amateur radio and I listen. Maybe there's somebody doing a call. The call protocol is they call CQ, and so my call is N3CK. So I would say CQ, CQ, CQ. This is N3CK, N3CK, N3CK over. And somebody will come back and they'll say, you know, N3CK, this is WB4ABC. You know, name here is Fred. Your signal is 5.9, so it's signal strength and tone quality. Over. And then I would go back, you know, and then we exchange where you're from, where you're located, and there might be a little bit of bantering back and forth. You might make a friend. One of the things with amateur radio is that it really is there to design to help foster international relationships. And so you can meet friends with radio logs. There's a website called QRZ where you can log all your contacts. And there's other websites, EQSL, where again you can log your contacts, exchange cards. Having international camaraderie, with learning about each other's cultures, and broadening our views of the world is a great way to go. Probably TMI I just gave you, but
Yeah, we can add that in an email. So fascinating question. What errors do you see in communicating? Oh, let me try that again. What errors in communicating do you see sea kayakers and small vessels make?
so I think that the biggest error is they probably do not fully appreciate the need to have a radio. My friend that I was telling you that goes out and does sea kayaking, I said, "You carry a radio?" He says, "No." I said, "Well, you need to get one." And he went out and got the radio that I told him to get. And every time I speak to him, he says, "I can't tell you how helpful that was because you can get navigational information off it, you know, GPS location, exactly where you are. If you have, again, that DSC, if he gets into trouble, he can get immediate call. And it's not something that you have to get on a radio and say, Mayday, they flip the switch and press the button and they know where you are. One time he says, I was locked in by fog. I didn't know where I was. And that helped me navigate back to shore. So because he knew his GPS location, he knew where the land was, and he was able to navigate to safe harbor. So that's the other biggest thing with well, it's not communications, but of course wearing PFDs. You know, safety first.
Well, here's another question that is sort of related to the last one. If you have an emergency, can you use your cell phone to call 911 and get help?
You use whatever tools you have in an emergency. And even FCC regulations it can be abrogated in a bona fide emergency. That's the only condition where the government regulators will not, you know, enforce the rules to respond to an emergency. So yeah, if you don't have a marine radio and all you have is a cell phone, make sure it doesn't get wet. If you happen to be out on the water, you have to think about if that's your plan. You're going to want to make sure that you're within cell tower. Coast Guard does not monitor cell calls, so that's something that you want to take into consideration. If you want to go out just with a cell phone, you might get a 911 operator, but it may take a little while before they contact the Coast Guard and then, you know, relay information where you are. It's completely not advisable, I think, for any auxiliarist, and I include Sea Scouts, and you are professionals just like we are. I learn every day in the auxiliary. You're learning every day, and so you need to adopt the tried and proven methods of communications.
But if you have both a cell phone and a VHF radio, which is better for calling for help?
If I have a marine radio, I'm going to reach for a marine radio first if I'm out on the water. Now, having said that, part of our protocol when we responding to somebody that calls for a mayday is that I ask, do you have a cell phone, and give me that number, because their marine radio battery may die, and that's all they have left is a cell phone. And so again, preferred method is marine radio. But I want to know all methodology that I can contact and communicate with that person. So I'm not gonna say no to a cell phone. I'm just gonna say that should be your second line.
We have two more questions. First is, do international vessels monitor 1.6, and should they respond to communications in U.S. waters?
I believe that every mariner has got an obligation to respond to a mayday call. I've Even though I was in the Air Force, I spent a lot of time on cruise ships, and being in the auxiliary, I always try to get my way up onto the bridge and talk to the folks. And yeah, they were monitoring channel 16 up on every major cruise line I've been on. They do that because it's an obligation. I guess if if you're a certified captain of a vessel of that size, you're going to provide assistance in a mayday situation. So we're all out there to help each other.
So next question's on how to go shopping for a new Sea Scout ship. And I would like to contribute out after you do, but it's a great question. For a new ship, what type of portable radios do you recommend?
Well, there's several reliable manufacturers that provide I'll say equivalent comms. Um, the only two I can think of offhand are the two that I have. One is the Standard Horizon. That's the radio that I have. The others are ICOM is another manufacturer that makes marine radios. What I would do, and I'm not here to promote any particular manufacturer, and I apologize for all the others that I didn't identify. But I think first, just Google marine radios. Take a look at what their capabilities are. So some of the things you want to know is, do they have a dual watch capability, for example? Do they have scanning capability? Do they have weather frequencies? Can you access weather? Because that's another valuable resource that a marine radio will provide to you, and will actually give you an alert in severe weather conditions that may be coming through your area. I'd want to look at, again, what power rating they have. Usually if it's handheld, they're going to be limited to 5 watts. And so you kind of look at the design of the radio, ease of navigating through the menus. I always like to go to a store and put my hands on a radio to kind of get a sense of it. Some of the radios, the Standard Horizon that I have, you drop in the water, it will still float. So that's a good feature if you're out on the water. So those are the types of things you look at, and then price performance. Can you afford the the radio? I've never owned a Mercedes-Benz or a Cadillac, so but I've had reasonably good cars that got me from point A to point B.
Oh, and one other point is the battery life.
Affordability.
Yeah, some portable radios have better battery life than others.
And is it something that's chargeable, or is it something that you could drop a couple of alkaline cells in it as a backup? So does it take dual power? Good point.
I would add, for program aspect, you absolutely want to pick a couple great VHF radios, whether it's handheld or if it's installed on your vessel, depending on the type of boat that you have. But I would also recommend some of the family radios, the FRS ones, because those can be great. So you're not tying up the VHF radio if you have, say, scouts out on kayaks, so you can communicate with each other. and stay in touch with people while they're doing adventure, they're doing scouting, and have that means of communication with your scouts who could be out in small boats and doing program activities.
Right. Just one caveat there is I'm pretty confident FRS doesn't require a license, but
No, it doesn't.
GMRS does, and that's also a handheld radio. You generally have just slightly higher power than an FRS, and they do require a license, and it's not cheap. I think it's about $60 for I think five years, but it's still a chunk of money that you have to put out. So just make sure you don't get one of those without getting a license.
There was a question that came in chat that we missed, and I want to be sure that we get to it. And it says, is there a compatible system in the interior of the country along the major rivers and dams? I'm not sure what that pertains to. Nick, can you?
I believe you might be referring to Rescue 21, and the answer is yes. So it's along the Great Lakes. I know it has a certain part of the Mississippi River. I don't know positively if it's the entire Mississippi, but I wouldn't be surprised if they had some type of communications along that major waterway.
And we do have someone who has a hand raised, or at least might be typing. Whoever just raised their hand and then put it down, please use the chat function or the Q&A. And
these are great questions. I really appreciate that.
yeah, this has been one of the best nights for questions that we've had. So thank you, everyone.
While that person is thinking about their question, I have one. Do you have to have a ship station license to register the radio's MMSI number?
No, you don't need a radio license. Recreational boating is not required to maintain an FCC license. There are some caveats if you happen to be, take your boat out to a different country, and I'm just thinking of Bermuda, let's say, if you go that far offshore, and you're operating in another territorial water, there are some limitations there. So whenever I go out on a cruise ship, usually the captain doesn't like you to carry a marine radio. They basically confiscate it and say, we'll give it back to you when you get off the ship. But I've tried amateur radio, even though the cruise lines say that you need to get permission, even though I tried, but was never successful at doing that. So.
Yeah, you don't want to board a commercial flight wearing a parachute. That tends to upset the flight crew. So we just had a bunch of comments come in, and one is, I presume it's use VHF on land. And can you share if people do that?
Difference between VHF and HF is frequency. Now, what's the difference between the two? VHF is line of sight. So I have both VHF and HF equipment, part of my amateur radio. VHF, like I said, line of sight. So you don't go too far with it, maybe 20 miles, depending on how high you are, whether you're on a mountain ridge overlooking, a valley, you'll get much further distance. But what they do have is repeaters. And so a lot of different radio clubs and what have it will establish a repeater. And what a repeater does, it listens in on one frequency and repeats the exact same audio signal on a different frequency, usually about 600 kilohertz shift between input output on 2-meter operations, and I believe it's 500 on a UHF, which would be the 440 range. And again, if you look at that spectrum, you can see the different spectrums. Amateur radio, we generally operate on 160, 80, 40, 20, 15, 10. And then we go to the 50 megahertz, and then 2 meters, which is 144, 70 centimeters, which is 440, and then we even go up into the gigahertz range. So all those different frequencies. So use repeaters to get a longer distance. Usually you're going to get 40 to 50 miles. There are some repeaters that are really high up on a mountain. You go out to the Rocky Mountains, and you can see forever. Again, line of sight communications. HF, you're taking advantage of the ionosphere and bouncing a signal off of the ionosphere as well. VHF will cut through the ionosphere, and you can even get a small handheld directional antenna and try to communicate with the International Space Station. NASA's got a website. You can see when it's flying over your neighborhood. The International Space Station generally always has a ham radio operator on there, and public service, they will communicate with the ground. Just Google on YouTube, ISS amateur radio communications. They got several websites that you can actually see how that happens. They actually show both sides of the communication. Something else to get interested in. Hope that answers that question.
Yeah, thank you. That was fascinating. We have a few comments, and we'll just share those. Several people who sail on Lake Superior say that they have DSC, and that if they go to Canada, they need to acquire a license for their radio communications. And yeah, so very, very engaged audience tonight. So I'll turn it over to Bruce for closing us out. And Nick, this has been a lot of fun. Thank you.
My pleasure.
Yeah, thanks so much, Nick. I just want to remind everybody that our next Coast Guard Tech Talk will be in January. We're going to be taking November and December off. November conflicts with Thanksgiving, and December conflicts with Christmas, New Year's. So our next Tech Talks will be on January 26th at the same time. And the subject will be maritime safety equipment. So I'm going to ask Nick to send his PowerPoint and his the web links that he referenced, and we will add those to the wiki, and we will let you know on Facebook when those have been posted. And we should also have a recording of this presentation in the next day or two. So we'll let you know when that's available. So thank you everyone for joining us this evening. Nick, you did a great job, and we'll see you folks in a couple of months. Good night.
Good night, all.
As for where on Facebook, on our Facebook fan page, Sea Scouts BSA, and YouTube channel, Sea Scouts BSA. Thank you all and have a great evening.